Alright guys and girls, let's talk about practice test 6. So I draw an angle with the given measure and standard positions. 7 pi over 6. So it might be useful for you to convert this into degrees, those of you that aren't as good with radians. So if we times by 180 over pi, 7 times 180 divided by 6. Now, I'm not timesing by the pi here because the pi's will cancel top and bottom. So this is the same as 210 degrees. So remember, quadrant 1 is from 0 to 90, non-inclusive. Quadrant 2 is from 90 to 180, non-inclusive. Quadrant 3, 180 to 270, non-inclusive. Quadrant 4, 270 through 360, non-inclusive. So this would be in quadrant 3, and that's all I'm looking for. That you draw an angle in quadrant 3, label it as 210. This, negative 10 degrees, you might want to make that into a positive measurement by adding 360 to it. So negative 10 is the same as positive 350. So it's in quadrant 4. So there's negative 10 degrees in quadrant 4. Or you can think of it as 0 through negative 90 would be quadrant 4. Negative 90, negative 180 would be quadrant 3. So 0 through negative 90, 0 through negative 180, or excuse me, negative 90 through negative 180, negative 180 through negative 270, and negative 270 through negative 360. We all think of it that way. So negative 10 is the same as positive 350, or you can think of it as negative 90, going backwards 10 degrees. Alright, so convert to radians. We're going to times by pi over 180. I'll accept 3 types of answers here: a decimal, a fraction, and a reduced fraction. So the fraction, the reduced fraction's answer, 150 divided by 180, is 0.833. So this is equal to 0.83 repeating pi. So I'll take that as an answer. I'll take it as a fraction, 5 pi over 6. Or I'll take the decimal answer, which is 2 and 62 hundredths about. I'm putting an approximate sign here. 2.62. Any of those 3 are fine. Don't mix the 3 up though. If you're going to give me an answer in terms of a decimal, just give me the decimal, 2.62 about. If you're going to give me an answer in terms of pi, give me the answer in terms of pi. That's a decimal or fraction. Pick one. Alright, so this one times by 180 over pi. The pi's again will cancel just like on question 1. When you're converting into degrees. So 71, if you times it by 180 and divide it by 12, you'll get the degree measurement. So this is equal to 1065 degrees. I didn't ask for you to make it coterminal, so that's fine. You don't have to do a coterminal angle there. Oh, and on this one you can have any of 3. So I should check all 3 of those. Alright, so again, this is question same as question 1 and 2 here, these ones here. Just tell me which quadrant it's in. This one's easier than this one probably because this one's in degrees. This is in quadrant 3, between 180 and 270. This one, you might want to make it into degrees. If you don't want to make it into degrees, you can use the radian measurement as well. Times by 180 over pi. The pi's again will cancel, so 180 divided by 6 is 30. And it's negative. And you can add 360 to that. It's not quadrant 1, it's quadrant 4. Because you can add 360 and you can get 330. Alright, positive coterminal. Make sure you add 360 or subtract 360 until you get something between 0 and 360. So when I add 360 once here, I get an appropriate answer. But that doesn't mean you just have to add 360 once on the question. What it means is add 360 or subtract 360 until you get something between 0 and 360. 0 and positive 360, like question 1. So you can say, you know, what its reference angle is for the quadrant number. Alright, this one, coterminal angle, you can add and subtract 2 pi or you convert to degrees and then back into radians. It might be easier just to add and subtract 2 pi. So it says find a positive and negative coterminal angle. You're going to add and subtract 2 pi to that. Now it is in fraction format. So 2 pi is the same as, in fraction form with 45ths, 90 over 45. Why 90? Because 90 divided by 45 is 2. Or you can think of it as 2 times 45, the fraction part of that. So I'm going to take 49 plus 90. 49 plus 90 is 139. I'm going to take 49 minus 90, negative 41. Option A. A lot of you missed that one on the last quiz that we had last week. Week before last? Yeah, week before last. Anyways, there's the first page. We do have, in this case, I believe it's 27 questions. So I will try to make it out of 100 points total. So maybe that'd be 3 points each. Makes sense? 3 points each, 4 points each. 4 points each. 4 points each makes better sense. Make it out of 108. Alright, find a reference angle, answer in degrees. Wow, that is the same as this, except, as this one here, except now we're looking for something between 0 and 90. So it just so happens when I add 360 to this one, I get 40, which is a reference angle between 0 and 90. Now, keep in mind here that reference angles are always between 0 and 90. So if I'd added 360 and I've gotten something in quadrant 2, 3, or 4, I would have had to do extra work. So in quadrant 1, it's just the angle. It's whatever the angle is. But if I'd gotten something in quadrant 2, I would have taken 180 and subtracting the angle from it. So for example, if this, instead of being 320, had been, I don't know, 250, negative 250. So if I got negative 250 plus 360, that's in quadrant 2, 110. I wouldn't have left it as 110. I would have said it's 70, the reference angle, because 70 has the same sine, cosine, and tangent as negative 250. And you can check that. Sine of negative 250. Negative 250 is the same, the decimal value here, I'm sorry, I got to push the equal sign, 0.93, as the sine of 70. 0.939. See? So again, because it's a quadrant 1, that's fine the way it is. But if it's quadrant 2, I would have subtracted from 180. If it was quadrant 3, I would have taken the angle, take away 180. So if this had been, 185, I would have had 5-degree reference angle. Or if it would have been 250, I would have had a 70-degree reference angle. And if it had been a quadrant 4 angle, I would have taken 360 minus the angle. So if it would have been like 315, it would have been 45. Just keep that in mind. Alright, convert the decimal degree into degrees, minutes, and seconds. So there is a key on the 84s if you're using the 84s for this. On the 30x's, there's no key for this. So, the proper thing here, we got 14 degrees. The 0.615 is out of 60. So I'll take 615 divided by 60. That's 10. That's 10.25. So that tells me 10 minutes. Sorry, 10 minutes. And then the other one, we'll take 25 out of 60. I believe it's dividing by 60. I forgot if it's dividing by 60 or timesing by 60. Let's look it up in the notebook. It's been a while. Hold on a second here. Let's look this one up, make sure we do it properly. We got time here. Nope, it's times by 60. Good thing I looked it up in the notebook. You're supposed to times by 60 here to convert from decimals into degrees, minutes, and seconds. So I did not want to do 0.615 or 15 divided by 60. Nope. I wanted to do 0.615 times by 60. And that's the proper way. 0.615 times by 60 is like, this doesn't work out properly. So that's 36.9. That tells me 36 minutes. And then I'm going to do 0.9 times by another 60. Which is 36 seconds as well. Oh, 0.9, not 0.6. 54 seconds. Again, the 84s does have a key for this. Let me show you on the 84s. So, if you're using the 84s, turn this on. If you're using the 84s for this, you can do 14.615 second angle to degrees, minutes, seconds, and it does it for you. 14 degrees, 36 minutes, 54 seconds. Again, that's under the angle key. So you type in the decimal, 14.615 second angle, and it's the fourth option. Option 4. So that might be easier if you practice it on the 84s. If you haven't practiced it in times by 60 twice, it would be probably just as easy to do. Alright, next thing. Find the length of arc, do not approximate pi. I really don't care if you approximate pi or not, so I probably should have taken that off. I'll give you the form S equals R theta. Remember, theta's got to be in radians. So this is going to be 5, not S, 5 times 240 times by pi over 180. So I'll take 3 answers here. You can do 5 times 240 divided by 180. This is the answer in terms of pi. 6.6 repeating pi. 6.6 repeating pi. So there's one answer I'll take. I'll take it as a fraction if you want to do it as a fraction. 6 2/3. Or you could say that's 20/3. 20 pi over 3. And I'll even take the decimal if you want to leave it as a decimal. Times by pi. About 28.9. These are all in feet. We should include units here. So any of those 3 answers are fine. I don't care if you approximate pi. The calculator, you can use pi there, and it's just a good exact answer. Alright, next one. Area equals, it's 1/2 r squared theta, I believe. Make sure I do the right one here. Yep, 1/2 r squared theta. And during the test, I'll put the formula up for you. I don't care if you memorize the formula or not. 1/2 times 11 squared. The theta's in radians already, so there's no conversion this time. That times them by pi over 180. So 1/2 times 11 squared times 2 pi over 3. And again, I'll take 2 answers. 1/2 times 11 squared times 2/3. So 40.3 repeating pi. That's in square inches. Or you can make it into a fraction, which is 40 1/3, or 121 over 3. Pi square inches. Or you can give me a decimal, 126.7 square inches. I'll take any of those 3 answers. Next one, convert from RPM to radians per second. So 500 revolutions over minutes. We're going to times by 60. Because 1 minute, 60 seconds. Actually, we're going to divide by 60. We're going to times by 2 pi. 2 pi radians per revolution. So there's my conversion. So I'm going to take 500 divided by 60 times 2 pi. And you can leave it and you get in 3 different ways. 500 times 2 is 1,000 divided by 60, 16 and 2/3. So that's 16.6 pi. Or you can make the decimal version of that, times by pi. About 52.4. Oh, I wanted the 3 spots. So about 52. Sorry, turn the lights off. 258. Or 26. 36, sorry. That's now in radians per second. Alright, trig functions, cosine, adjacent to hypotenuse. I don't have the hypotenuse labeled here. I have to use Pythagorean theorem to find it. So 7 squared plus 23 squared is 578. So this is the square root of 578, which is square root of 578, about 24. So this one I'll leave as approximate value or root value. 7 divided by the square root of 578. I don't care if you rationalize it. That's fine with me. Alright, this one, same thing. 5 squared plus 12 squared, 169. And the square root of 169 is 13. Just checking the last one. Secant. Secant is hypotenuse over adjacent. It's the reciprocal cosine. Alright, so secant goes with cosine, cosecant goes with sine. So I got 13 over 5 instead of 5 over 13. Alright, next one. Eliminating denominators. We're going to times this one by 2, top and bottom. That's going to double this fraction and this fraction to get rid of the 2 in the bottoms there. Alright, so after I times by 2, I'm going to have u minus 4 plus 4 over u divided by 24 over u minus 4 minus 25, like so. Next thing is I'll times by either the u or the u minus 4. You take your pick. Let's do the u. So that'll times by the u here. It'll be u squared minus 4u plus 4. Y plus 4 because there's a 4 there and the u in the bottom there. Divided by, and then neither of these have the u. So 25 over u minus 4 with the u in the top, and then minus 25u. Alright, last thing here, we'll times by the u minus 4, top and bottom. Now, it's going to be more useful here to leave this as parentheses in the top, because it might be factorable in the end. So I'm just going to leave that as a factored u minus 4 in the front with the u squared. And that u squared minus 4u plus 4 actually factors as well. But I won't factor it yet. The u minus 4 here will cancel that u minus 4. And we'll have a 25u, sorry, minus 25u squared minus 4 times 25, that's plus actually 100u. Now whether or not this factors depends on it, just depends. So this one, they all divide by 25, so I'll take a 25 out of that, and once I take that 25 out, of all three terms, I'll have a u squared, a 25u, or not a 25u, a u squared, and a 3u. Or just a u on the front and then a u minus 3 in the bottom. It would be nice if that was a 4, but it's not a 4 because of what happened here with the equations. So if it was a u minus 4, I would cancel that u minus 4 there, but it doesn't. So again, these two will combine. I'll get my finished answer, u minus 4. I could factor this as well. U minus 2 squared over 25u times the quantity u minus 3 with that negative there. There we go. That's it. And that one's a longer question. That one's probably the longest one on here. I tried to look at that one and make it so that it's reasonable on the test. And then I'll practice test here. Alright. Next thing. Tangent should be y over x. If I choose sine or cosine, make sure you find r. This one I didn't choose sine or cosine, I chose tangent. So I just got to do 19 divided by negative 14. Now if I chosen sine or cosine, I would have did 19 squared plus 14 squared. I got 557, and I would have had to use that as the r value. So if I chose sine of theta, it would have been y over r, 19 over square root of 557. That doesn't square root evenly, that's why I would leave it underneath the square root. If I chosen cosine, negative 14 over the same thing. Alright, again, so I'll make 4 points each here. Try to give you points for partial stuff like finding the hypotenuse on these, or multiplying by something proper on this, or plugging in things properly on one of these. Alright, last page here. Without a calculator, evaluate trigonometric function. I don't care if it's a calculator on the whole test. So you can use a calculator to help you approximate them, and then you can convert them into the exact values. I've got the unit triangles on the board. So this is the sine of 180. So these are all in radians. This is the same as the sine of 180. And luckily for you, 180 is actually a nice round number for sine. It's 0. So there'll be a few of these where you don't actually have to, think about what the actual value is. Pi over 6, 180 divided by 6 is 30. Sorry, 180, not 155, 150. So this is the same as the sine of 30. Now the sine of 30 is a half. So that actually works out pretty well as well. Now if I had chosen, instead of the sine of 30, I'd chosen the cosine 30, you would have had to figure out that the cosine 30 here, when it comes up as this, I don't want the decimal value here. Cosine 30 is square root of 3 over 2 from the unit triangle. Or you would have had to think about what is this 0.866. It is the square root of 3 divided by 2. Alright, so that's what we're talking about here with the exact value. We want the exact value. This is the cosine 45, which again is not an exact value on the calculator. So I'm going to have to look at the cosine 45. I'm going to have to determine that's 1 divided by root 2 or root 2 over 2. So just keep that in mind. I'm not going to take 0.707. We don't want the decimal value here. That's why it says without a calculator, but I like to use a calculator to get the decimal value to help you get the exact value. Again, the unit triangles are on the board. And the tangent of 3 pi over 2, well, 3 times 180 divided by 2. Notice how we're doing pretty much a whole lot of converting to degrees. That's kind of what we want to do here with these kind of questions. Convert it to something you understand pretty well. So that's undefined. That's 1 divided by 0. Because tangent 270 is pointing straight down, and the y value there is negative 1. The x value is 0. Alright, so find the period. Period is 2 pi divided by b. B here is 8. 2 pi divided by 8, pi over 4. I do want the fractional version here, not the decimal version, because periods for functions should not be decimal versions. Amplitude, A here is a fifth. Those two are pretty quick questions. They're just about the graphs we've been doing. And then the final thing here is the graphs, which you can look at our notes to get these 3 or 4 graphs, because they're all in our notebook. I'm not going to take the time and do them because I'm running short on time here. Got to start class pretty soon. But these are all in our notes, these graphs here. You got to find A, B, C, and D. The D is I'm not going to have the phase shifts for any of these, just A, B, and C. And you're going to have to, sorry, A, B, and D. Not going to have the phase shift, not to have the C. You're just going to have to graph them with one wavelength for me. Anyways, this is your test. Good luck. Hopefully you do well.